All right, so the last video we finished talking about how to find probabilities or areas under the normal curve when we were dealing with z-scores. Now we're going to put that together so we can do some real life questions. The way this works is a direct calculation as I have here. Essentially, we can, for any observation from a normal distribution, convert that to a z-score, and then convert that z-score to a percent. So we've already done both parts of this previously. We did converting to a z-score in part 2, and we just covered converting a z-score to using a z-score to find a probability or area under a curve. So both of these things we have done before. So our first example here tells us to assume that college women's heights follow a normal curve. This is the thing with these normal distribution questions for part 5. I have to tell you that they are normally distributed. So you have a big heads up that you should probably be drawing a normal curve so that way you can answer your questions with a visual to help. As we keep reading, we see that we have a mean height of 65 inches. So we'll use our mu to denote that. And there's nothing here to tell us that this is from a sample. In fact, we have the word assume, saying let's pretend this is the real thing. And again, we're right now in true math land where we have these parameters that we don't normally have. Later we'll be back in stats land where we have sample data and statistics. And then that last piece here, we have a standard deviation. So we'll use our sigma of 2.7 inches. Our question is asking us to find the probability that a college woman selected at random is shorter than 62 inches. If we wanted to use the notation for this, right, we actually know that we're talking about college women's heights. They are normally distributed with our mean of 65 and our standard deviation of 2.7. That's using the notation 2 pages ago. It was this squiggle line notation. X follows a normal with the mean and standard deviation. So if we want to use probability notation here, we can say that our x, which is our random normal variable, or woman's height here, is less than 62 inches, right? Shorter than 62 inches. Again, this doesn't give us a whole lot of information. So I personally like drawing my curve. So if I were to draw my curve here, now we're not talking about a standard normal. We're talking about something centered at 65 inches, a woman's height. So we can put down a mean of 65 inches, and we're interested in someone being shorter than 62. So 62 is somewhere shorter than 55, right? So, or 65, somewhere to the left. And then we want to know about being shorter than that. So this is the area under the curve that is represented by this probability. So you got the probability notation, and you have the area under the curve. Either is fine to represent what we're looking for. Now, looking up here, we have our first step. We need to turn that x into a z-score. We don't have a table that is centered at 65. We don't know exactly what that is. We do have a table that is centered at 60, or that is centered at 0. So if you wanted to do this by hand using the table, your first step is to convert that x to a z-score. So we know our z-score is x, our observation, minus our mean divided by our standard deviation, which is our 62 minus that mean of 65 divided by 2.7. So 62 minus 65 divided by 2.7. So we get out a z-score of negative 1.11. All right. Now that we have a z-score, we could actually redraw our little curve, right? Or we could, that is a terrible looking normal curve, or we could rewrite our probability notation. The probability that an x is less than 72 at a college woman's height is less than 62 is the same thing as a z-score being less than negative 1.11, something being 1.11 standard deviations below the mean. And we could, of course, revisualize that. Z-scores are centered at 0, negative 1.11, and we're interested in less than. So this is the same area under the curve. We've just done some transformations. So if you've taken a pre-calculus class, we've done a shift and a horizontal shrink. So we've done both of those pieces. So this, we could go straight to the table and look up. So if I were to grab my table, I needed a negative 1.11. So let me erase the stuff we did before. Negative 1.1 1. There's our probability, our area under the curve, 0.1135. So that's our area, 0.1. Did I say 11335? I think it was 1335. Yes, 1335. So there is our probability. Makes sense based on our drawing. We had something less than half. Now, of course, for those of you who have the stats wizard on your calculator, you're probably going, why did I do all of that work? Because if you remember in the calculator, especially if you have the stats wizard, this is really obvious, or the 36X Pro. If we were to go back into that normal CDF, my wizard's on again. Remember, we didn't have to just put in the lower and the upper. We could put in a normal CDF, which will do all of this work for us. We could put in the lower, then the upper, then the mean and the standard deviation. And so in this case, we could skip all of this work and just go, oh, if we look at our original drawing here, well, the lower bound, remember, it keeps going forever this way, so our lower bound is negative crap ton of 9s. Now you see here in my calculator, it's actually already autofilling to negative 1 e to the 99. So this is actually doing negative 10 to the 99th power. So we don't need to even change that. We do need to put in our upper, which in this case, the upper bound on what we're interested in is that 62. So we'll put that in. I don't need it. I'm so used to not having my stats wizard. And then you need to put in the mean and the standard deviation. So we're going to change it from 0 and 1 because we actually have a mean and a standard deviation here. We're going to put in 65 and 2.7. So even if you don't have the stats wizard, you're just going to you're going to add more commas than we used in the last one and put in all of this information in a row. As long as you put it in the same order as this stats wizard is, it will work. In fact, that's all it does is it pastes this on my screen just like you would type it in if you were doing this by hand. And if I press enter, there we go, we get out 0.1333. Slightly different because we rounded this z-score to 2 decimal places because that's the best we can do with the table. Whereas if we're using the calculator, it can actually keep all of those extra ones and find this value a little more exact. So again, the calculator value is more exact than this value we got from the table. So from here on out, I'm going to use the calculator method. You can use the table method. I've worked it out here for you the one time. It does just involve finding your z-score and then doing what we did in the previous video. But since we should all have at least that 36X Pro, that little $20 calculator, there's no reason for us to do more work when we can do this. So we have 2 more questions that come with this. Both are asking us to find probabilities, which means area under our curve. So if we want to skip the probability notation, we can just start by drawing our curve. Mean is still 65. One is telling us that we want more than 68. The other is telling us that we want between 60 and 68. So I want you at this point to take a moment, pause the video, try to do this using the normal CDF function in your calculator. All right, so coming back, the first one is 68 and we want more than. So if you're using your calculator, you should have done normal CDF. Again, we will never ever use normal PDF. In this case, the lower bound on what we were interested in is that 68. Upper bound, there is none. It keeps going forever and ever and ever that way. So we'll use a crap ton of 9s to make sure that that's clear. And by the way, this crap ton of 9s is totally relative to what your mean is. The worksheet we're going to do on Thursday, the mean, it's talking about salaries. And the mean is like 60,000. So if you just did this, you're actually below the mean. So you need a crap ton of 9s in that case. Or again, use that little E99 thing. I'll show you how to do that. I'll turn off the wizard and show you how to do that without the wizard. And then we need our mean and our standard deviation. So I'll do that in here. I'll turn off my wizard so it looks like the people who have the older calculators. Oh no, come back. I worked so hard for this. All right. So I'm going to go back to my distributions. I'm going to grab normal CDF, and I'm going to do 68. Here's where I can put in my crap ton of 9s, or if I want to use the notation that they did, The little e, the exponential button, or the scientific notation button is here. You see it above the comma, so I'll do second and then the comma. If you do E99, then you know that there's no chance that you're not far enough into the infinity area. But again, you could just use a crap ton of nines if you don't feel comfortable or know what that is. Our mean is 65 and our standard deviation of 2.7. Turns out that this probability is the exact same as before, which actually makes sense. Before we were 3 below the mean, and here we're 3 above the mean. So they're actually symmetric. These two problems that we just did are symmetric. In fact, if we had done the z-score for this problem, if we had worked through that, the z-score is a positive 1.11. So, clever. The last question, again, if you didn't pause, I strongly encourage you to pause. This is actually the easiest one to do. But if you did it, we're looking at between 60 and 68. Again, this does not have to be drawn well. This is our visualization. That's what we're looking for. So when I go to normal CDF, I'm going to do the lower bound of what I'm interested in, 60, the upper bound, 68, my mean of 65, and my standard deviation of 2.7. So this one is particularly easy in that I just did my second enter to bring this back, in that I don't have to do anything crazy in terms of that E99 business. I don't have to think about infinity at all because I have bounds on both sides. I can just press enter, and this is 0.8347. Doing with this with the table requires me to calculate not only one but two z-scores, then look them both up and subtract the smaller probability from the bigger probability. So again, calculator is going to save you a ton of time, but on the test I do give you the table, so if you really, really don't want to buy a $20 calculator, you have that option.